Welcome to our first lesson of Chapter 1. Glad you found the video okay. We have variables and expressions today. Our objective is we will identify and write numerical and variable expressions. So let's get to defining those words. First of all, a variable. If we are not sure of a number or it can change or vary, we call it a variable. So the definition that's really important here is a letter that stands for a number. Make sure to get that written down. A variable expression then has variables in it, but this word expression has express in it. That means that you're saying something, but you're not saying it's equal to something. So it's really important to know that it has no equal sign. It is a mathematical phrase that uses variables, numbers, and operation symbols. So for example, x plus 3. X plus 3 has a variable in it, but no equal sign. A numerical expression is a mathematical phrase that only uses numbers and operation symbols, so no variable. 4 plus 3 would be a numerical expression. Now it's pretty straightforward, but let's look at two examples. The first one, 4x plus 1. The directions say to identify each as a numerical or a variable expression. For a variable expression, name the variable. So for 4x plus 1, that would be a variable expression because we see that the variable is x. This next one, number 2, 16 plus 17 minus 5, there's no variable. So that's a numerical expression. This is the most important part of today's lesson. We're going to be talking about different keywords that help us to identify which operation we're talking about. So right here, what I've highlighted in red, all of these are going to be addition words. So all of the addition words, total, more than, increased by, will signify that we're going to add. The next section here in blue, difference, less than, fewer than, decreased by, those are all going to be subtraction. If we keep going down further, product, times, that would be multiplication. And then finally, at the end, we have division. So keep these words in mind as clues. Remember, you're kind of like a detective trying to figure out what these words are trying to get you to do, and you're trying to write it in a more succinct way. So the first example we have here is 9 more than the number y. More than is our clue. We know that's addition, so 9 plus y. Thankfully for addition, it doesn't matter what order you're writing it in, but for subtraction it does matter. So this next one, 4 less than a number n, we know it's subtraction, but we don't know what order. So let's think about putting in a number for n. Let's say we put 10 in for n. If we put 10 in for the number n, 4 less than 10, we know that that would be 10 minus 4, which is 6. So if we put n back in, 4 less than a number n, if we did the same thing, would be n minus 4. It's actually backwards. I'm going to star that one because that's the one I see most people getting tripped up on. So now we have the difference of 4 and n. Difference is going to indicate that we will have to stay in the same order. 4 minus n. Next, a number z times 3. You can do z times 3, z times 3 in that way, or 3z. That's going to be the best way to write it right here because that's how we're going to see it used in pre-algebra and in algebra. Last two, a number y divided by 12, y divided by 12, or y over 12. Finally, we have 5 times the quantity 4 plus a number c. So whenever we have that word quantity, it needs to go in parentheses. 4 plus c. And it's 5 times that quantity. If we put a 5 on the outside of the parentheses, it means that it's being multiplied by whatever is inside. Look back through these examples if any of them you didn't understand. Now we're going to look at some word problems and change the words to a more succinct word and then finally to an expression. So first example, the fastest dinosaur could have run up to 60 feet per second. Write a variable expression for the distance this dinosaur could run in s seconds. So we know in words, if it's 60 feet per second, then it's 60 times the number of seconds, 60 times s. The expression then would be 60s. Another word that indicates multiplication is that word per. If you have $3 per ticket or 60 times per second, anything with that word per is going to tell you to be multiplying. Example 2 says the number of hours in m minutes. Now if you ever get stuck on a problem like this, put in a number for the variable. Let's say the number of hours in 120 minutes. So we know then we do 120 divided by 60. We're going to do the same thing now, except put in m for the number of minutes. M divided by 60, or you could have m over 60. If you get stuck, substitute like we did right here. This would be our final answer, though. Okay, here's a few more. Write a numerical expression for the number of feet in 100 inches. So it says numerical, so that means you need an operation, but it's just going to be numbers. So the number of feet in 100 inches. So we know that if we go from inches to feet, we're dividing by 12. So 100 divided by 12. Then it says write a variable expression for the number of feet in I inches. So the previous problem really set us up well. We know that however many inches it is, we always have to take that number and divide it by 12. So we've kind of created a formula right here for every time we have any number of inches. So here's your exit pass that you need to do on your guided notes. Please take a look at them, put them on your guided notes, and we'll talk about all of this tomorrow.